Hello friends, welcome back to our channel STM Mechatronics. So in this video we will continue with the previous topic, that is the interface of STM32 with ST7735 display. So this is one SPI TFT display, right? I have walked you through the code and I have walked you through the libraries that we have written. Okay, so one important topic that I wanted to clear, right? There was no clear understanding how we are driving the chip select pins, the data and command line, how we are transmitting the clock, and the data, how we are writing the data with respect to the clock. So I wanted to cover that in this video. That will give us better understanding how we should write the data to the TFT SPI display driver or to any SPI peripheral basically. So in this code we are not actually using the SPI peripheral of STM32. Instead what we are doing is we are toggling the GPIOs. What I will be doing is, like, I will walk you through the code and I will tell you like how we toggle the pins, GPIO pins, in order to achieve the SPI functionality to interface with the SPI TFT display. Okay, so in the last video, like everything, this part, right? In the last video this part was there. The additional component that we have added over here is an oscilloscope. Okay, so how you can select the oscilloscope is, you can go over here the oscilloscope in the instrument window, you can select the oscilloscope and you can place the oscilloscopes. Now to connect the oscilloscope, like we in actual hardware, what we do is we connect the oscilloscope channel probes to the GPIO pins or to the controller pins. The same way what we have done is, like, the 4 channels of the oscilloscope. So we have the channel A is connected to chip select pin, channel B is connected to data and command pin, channel C is connected to SCL, and then channel D is connected to SDA. Okay, here we can do, like, here we can try another approach also. We can connect a logic analyzer and see the signals over there. I'll cover that logic analyzer part in the some another video, but over here for our understanding, like, we will use the oscilloscope. Now the channel A of oscilloscope is connected to chip select. Chip select is on PB1, right? On PB3 we have SCL, on PB4 we have command, data and command, and on PB5 we have SDA, right? So these respective pins that we have connected over the oscilloscope channels. Okay, why we have done this? Like in the last video, like I have walked you through the code and I have told you, like, writing logic low to the chip select, right? Then we are writing logic high to the chip select. While sending the command, like we are sending either command, that is logic 0 and 1 for data. So like we are driving the command and data pin to logic 0 for command, and we are driving the command and data pin to logic 1 for the data that we want to display on the TFT display, right? And while, like, PB5 is the SDA, we are either driving it high according to the bit that we are selecting over here, right? Or we are driving it low to the low if the bit becomes 0, bit comes as 0. Okay, so likewise we are driving it over here. So I wanted to walk you through the code to understand it better. Okay, now what we will do is, like, I have already walked you through the code, but what I'll do is I'll just simply and slowly walk you through the file from starting to end. Okay, so this is main.h, this is SPI TFT display.h. Now we have private function prototypes, these are system generated. Okay, we have written all the functions, right? SPI display interface functions in the TFT display.c files, that is the library files. Now in the main code we have used one counter variable, color variable. Now going over here, now these are the user defined functions that we have written: display reset, display sleep out, display set column mode, then display set Mac control top to bottom, display on. And in the continuous while loop, what we are doing is we are displaying certain image, we are displaying certain color, then we are displaying certain patterns, right? Likewise, and then we are going on incrementing the color value that we are displaying, right? So it will start from either dark black, complete black, then it will turn to red, then it will go like from red to, it will start going on to black, and like, so from 0 value we are incrementing it by 10, then we are incrementing it by plus 10 plus 10 plus 10. So whatever the color, corresponding color, that will get displayed on the display. So basically we are going to display multiple color values. What we can do is we can increase this value by 100 and see the difference. Now this is system generated clock, system generated function. Okay, I'll minimize this. This is again system generated function that I have explained in the last video. Okay. Now I'll go to SPI TFT Display.h. Okay, here we have defined the pins that we have used for the SPI display interface. Okay, which pin is connected as chip select, which pin is connected as SDO, which pin is configured as clock, which pin configured as data and command, or it is written over here. Okay, now display command and data width, it is configured as 8. Now these macros help us to derive or write better code. Okay, now we have used enums to write the commands, display commands. Now again we have used another enum, command or data. Whenever we want to display command, right, we will write logic 0 to command and data pin, and whenever we want to display data, we will write logic 1 to command and data pin. So for that, like, we have used this command or data pin. We have made all the declarations in the .h file. Now in display.c, this is the code. Okay, again I'll slowly scroll through the code so that you guys can copy it. I have already explained these functions in the last video. You can get a reference from it. Few functions I will again discuss in this same video. Few functions I will again discuss in the same video for the better understanding how the pins actually toggle with respect to the function, or in the function how we toggle the pins to get to achieve the functionality or display the image. Okay. Now in the next video, what we will do is we will either use the actual SPI peripheral for the like TFT display interface, or we will optimize the code, right? We can go in both the directions. So we will see how we can optimize the code, and later we can see actually we can use the SPI peripheral, and using SPI peripheral we can achieve the better throughput, right? Better outcome or faster outcome. So we have reached the end of the .c file, tft display.c file. Okay, now we'll come, like, first we'll build this code. Okay, now that we have built the code, we'll load. Okay, and we'll start the file. So when we add the oscilloscope, right, oscilloscope functionality to the Proteus, the simulation becomes slower. So if I remove the oscilloscope and run the same code, right, you can see like it is simulating very fast. But when I add oscilloscope, it will simulate very slow because it is displaying the signals on the oscilloscope. Okay. And on the actual hardware, it becomes very fast. So over here, like you can see that the seconds are actually going on, right? But on the actual hardware, it becomes very fast. Now you can see the better shades of red. Earlier it was black, now it is going towards the red, right? Okay, so this way it actually happens. Now that we have added the oscilloscope and we will run it again, so you can see the signals over here, but at the same time you can see that when the display, it is loading very slowly. Okay, the colors are getting loaded very slowly. But what in this video what we wanted to do is, like, we wanted to see the signals actually, so that's why we are doing this. Now what we will do is, we'll just change the source to C and we can see the signal. If we switch it to B, right, now continuously data is being written, either 0 or 1. Okay, so we are writing black, that's why it is 0x0000, and that's why the SDA line is continuously low. Okay, so we'll restart the simulation so that we can see the data in actual lines. Okay, so what we'll do is, we'll just come over here. Okay, and once again we will run it, so then we can capture the signal. Okay, now here you can see that, like, earlier the chip select was high, right? The default state for all the pins were high, right? Even for the chip select, for the data and command, for the clock, and for the SDA, right? So SCL and SDA. Now you can see that the chip select becomes low first, then the data and command becomes low. This means that we are sending the command first, then we are sending the 8 clock pulses. So if you see, like 1 2 3 4 5 6 7 and 8, so starting from this to this. Okay, now if you see, like, we are sending 1 2 3 4 5 6 7 and 8, and in that 8 clock cycle what we are doing is, like, here it is 0 0 0 1 0 0 0 1, so we are sending 0x11h. Okay, now we will go in our code. So, like, in the display reset, what we will see is, first we are resetting the chip select. Okay, we are giving some delay, then we are setting the chip select. Okay, that way we are doing it. Now the second function comes as display sleep out. In display sleep out, what we are doing is, we are bringing the chip select to logic 0. Okay, we are bringing the chip select to logic 0. Then we are sending the command as 0x11. Okay, here you can see that we are sending the command as 0x11. Okay, and if you go inside this send command, right, we are writing logic 0 to this data and command pin. So data and command pin is connected to channel B. So we are writing the logic 0 to data and command pin before we write the data. Okay, now we want to send 0x11, right? So in the first iteration, what we will do is, like, we want to send the MSB, right? So we want to we will run this loop for 8 times, right? First is 80H, correct? So command code is 11H. So MSB is 0. MSB, so 11 and 80, the answer becomes 0. So what we get is 0. We send the data and then we right shift it by 7 times. So MSB becomes, like, the bit number 7 comes to bit number 0. Then we send the, like, we check if it is 0x00 or not. Okay, if it is 0, then what we do is, like, we set and reset. So PB5 is SDA, that we write it over here. If it is 1, then what we do is we set that particular pin, PB5 pin. Okay, if it is 0, what we do is we have to clear that pin, right? The bit set register, we will first clear it, PB5, and then we'll reset it. So we have to shift it by 16 times. What we can do is we can write the better code. So that I'll show you in the next video. So this is kind of confusing for you guys. Okay, so in the next video, what we will do is, so we will write the clean code for us to better understand it. Okay, now again we will go over here, bits set reset. Okay, then what we will do is 0x80, we'll write 1 to the clock, right? Then we'll wait for sub instruction, NOP instruction. Then we'll shift the bit, this 80 bit, so it will becomes 40. Okay, now we are not directly modifying this command code that has been passed. Okay, so we are keeping it as it is, right? Now that we have shifted it, we are again going bits reset, right, PB3. So we are bringing the clock pin high. Okay, reset, then set. Okay, now again we'll go over here. Okay, in the next iteration we will be sending bit number, we have already sent bit number 7. Now we will be sending bit number 6, right, that of the command code that has been passed on. So likewise, now if you go and see in the simulation, right, what we are doing is, in the first iteration we want to send 1x or 11h, right? So the MSB is 0, so we are sending 0, again 0, again 0, and 1. So we will be sending 1, again 0, 0, 0, and 1. Okay, like we have sent the first code. Now we'll run. Now it is continuously sending it. Okay, so what we will do is we'll capture it, recapture it again. Now we'll shift the horizon to A, capture mode to A, right? Now if I go over here and check, like, what is the function, because it captures very fastly, it is not visible over here, that we can capture it on the logic analyzer, right, and see the actual values. So now you can see that, like, the chip select pin again goes low, the data command pin is low. It means we are sending first command, and again after that we are sending, immediately after that we are sending the data. Okay, now if we check over here, right, it is 0, 0, 1, 1, again 1, 0, 1 0, right? So it means we are sending 3 AH. So 0 0 1 1 and 1 0 1 0 is 3 AH. Okay, and in the in the data, what data we are sending is like 0 0 0 0 0 1 1 0. So we are sending the data as 06H. So first we are sending the 3A command, and then we are sending the data as 06H. This is in one iteration before writing the next command and the data. So we will go into our code, right? Now that we have seen what command and data how we are sending, right? We'll go over here. Now we'll check in the next command what we are sending. So if we go into set column and mode, right, you can see that after bringing the chip select pin to logic 0, we are sending the data as 3AH, right? First we are sending the command, then we are sending the data as 06H. Okay, now whenever we are sending the command, right, this data and command pin is tied to logic 0, and whenever we are sending the data, this data and command pin is tied to logic 1. So over here you can see that while sending the command 3AH, the data and command pin is tied to logic 0, and while sending the data 06H, the data and command pin is tied to logic 1. Okay, now same goes for this set mad CTL top to bottom. First we are sending the command as 36H, and then we are sending the data as 00H. So while sending the command, data and command pin will be tied to logic 0, and while sending the data and command pin will be tied to logic 1. Okay, now what we want to do is we want to go over here. Right, now that we have captured over here, we want to measure this. We have already measured this, right? Now the command that we have sent is 36H. So 0 0 1 1. Again, if you can see, this is 0 1 1 0. So this becomes 36, and in the data we are sending as 00H. Okay, now if we come to next, right, next part, here we are sending two commands. Okay, so we will see that in our code, either we are sending the two command or two command bytes, right? Now here you can see that display on command 29H. Display on command 29H, right? So here you can see that what we are doing is, first we are sending the command 29H 0 0 1 0. This becomes 2, and for 9 it is 1001, right? So 1 0 0 and 1. So this becomes the first command. Okay, that is the display on. Now we will again come back to the while loop. In this while loop, what we are doing is we are sending the top to bottom 36 and 00H, right? So again we will come over here. Now we'll see over here, right, the chip select becomes low. That means we are enabling the SPI display. Okay, we are first sending the command, then we are sending the data. Okay, so this blue line, right, this is for channel B, which is connected to data and command pin. Okay, again, so 36 0 0 1. I'll use the cursor over here, so you can see that it is actually 0. Okay, 0 1 1, this becomes 3. Now 0 1 1 and 0, this become 36, and the data is as 0 0 0. Now we'll come over here. Now what we are doing is we are first sending the command. Which command we are sending here is first we will check over it here on the oscilloscope, and then we will later go into the code and we will verify. Okay, so it becomes the data becomes the command becomes 0 0 1 0. So it becomes 2, this becomes 1 1 0 0. So 2C is the command that we are sending. Now we will verify in our code whether we are actually sending the 2C command. Okay, so display image, we will go over here, right? We are sending the 2C command. Okay, and after that, for this resolution, right, 132 into 162, we are sending the data. So we are sending 3 bytes of data for each pixel. We are sending a single byte of data for each pixel. Okay, so 1 byte, second byte, and third byte. So likewise we are sending the data. So this we are doing for like 132 into 162. So total number of bytes that we are sending will be like 132 into 162 into 3, because for each pixel we are sending the data and we have total 3 pixels, red, green, and blue. Okay, so that means numbers of times we are sending the data. Okay, after that, like, we are sending the 0x06 command. Now all these things, right, I'm telling you, like, we are sending the command for 2C for memory write or display on, right? Okay, so what we will do is yes, so now that we have opened the ST7735 SPI interface PDF, right, this is the PDF for TFT display. Now you can see that we have various hex code for the different instructions, right? These instructions work in accordance with the TFT display, that is ST7735. Okay, now you can go and check like which command that we have written, right, is specifically for the functionality, which functionality, right? Now just before coming to this, like I have told you, like, we have sent 2ch. Now what this 2ch does is, like, it writes to the memory. Okay, and immediately after writing the 2ch, what we have to do is we have to send the data. Okay, so it will go and writing the data continuously, right? Similarly, in the datasheet it is written like how many number of bytes of command that you have to write and how many number of bytes of data that you have to write after sending the command. So here, like, simply over here, right, we are writing to the memory. So the memory is of like 132 into 162 into 3, like 1 byte for each pixel, that is for 3 pixels. Okay, so likewise we will be sending the data. Okay, now if you want to go into descriptive part and see like how many bytes that we want to send, actually we can go over in here in the section, okay, 10.20.1 and check. Okay, now for the display on, we have to simply write 29H, it makes the display on. If you want to make it the display off, we have to simply write 28H. So here, like, you can see that we have to only send the command 29H and no data after it. So that's why in the display on function, right, here in the display on function, we are only sending the command, not the data, and the command is like 29H. Here you can verify it, 29H. Okay, likewise, now that I'm telling you, right, we are writing the data and we are writing total 132 into 162 into 3 bytes of data, right? I will go into 10.1.21. So we'll go into 10.1.21 and we will check over here. It is 14, 18, 19, 20, I guess 20, right? And we are coming to the 21 part. So here it memory write, right? we are sending 2ch. Now first parameter that we have to send is like the command, that is 2ch itself. Then what we have to send is first parameter. First parameter is like D7 to D0, MSB to LSB. Okay, so from first parameter to nth parameter, and nth parameter can become like 132 into 162 memory bus. So from GM000 to like memory, whatever the range is, right, that we can write. Now if you want to write from the middle, what you have to do is you have to first set this GM, right, from where you want to write. So you have to write the memory address first, and then you have to write the data. Now this is the flowchart, right? You send the command, then the parameter, then display, then action, mode, and sequence. So right, RAM write you have to send, then you have to send the image data, and then you can send any command. Okay. Now after coming back to this, right? Now once the image is displayed, now this image displaying image will take a lot of time. We will keep it continuously running. Okay, or we will just wait over here. So first we are writing the black image, right? Then the screen color FF, right? So the data, like data pin will be 11. Now it is continuously writing. Okay, like we will go into screen color, chip select, we have made it to logic 0, we have tied it to logic 0. We are again send the 2ch. Then what we are doing is we are writing the data, we are tidying the data to pin to logic 1. Then we are writing FC or this, and then we are sending the data. Okay, so this is fixed color. Okay, this is fixed color. Now why we have made it FCH? So in the last video that you can remember, for each pixel we want to send only 6 bits of data. Remaining 2 bits of data, it is negligible. Okay, so last 2 bits, bit number 0 and bit number 1, are ignored. So it is kept as 00 only, and rest of the things that we are sending it as 11. Okay, now whatever color that we are sending, right, first 12 bits will be used for color, red color. Next will first 6 bit will be, so most MSB significant 6 bits will be used for red color, middle 6 bits will be used for green color, and last 6 bits will be used for blue color. We want to pause it. Okay, right after it starts the command. We'll make it to 1. We'll keep it as single shot. Okay, now you can see over here, right? Now again we are writing the data. Okay, that is 1 1. So here you can see that last two bits are sending as 0 0. For each pixel we are sending the last two bits as 0 0. Okay, that's why you are seeing that data pin is going for 0 0 for the last two bits. So likewise we are writing the each function that we have written is going like in the display color. What we are doing is basically we are making the last two bits as 0 0, okay, for each pixel, and then we are sending it as data. So like while we are sending the data, the command and data pin is tied to the logic 1. Okay, after completing everything, what we are doing is we are sending the command, that is 0x06. That means it is displaying the data. So if we see 0x06, it stands for so here if you see 0x06, right? So somewhere here, like you can see that it is a command. Okay, it is command for sending the data. Okay, now like coming back to the next function, control and display image 1. Okay, in the display image 1 we are again doing the same thing. Okay, we are making the last two bits as 0 0. We are tying the data and command pin to logic 1. Okay, and then we are setting the endpoints. Now here like you can see that the pattern that we have generated, right? The logic is very simple. We know that like for the rectangle, right? If we consider the display screen as a rectangle, okay, the starting point will be 0x00. This point will be 0 comma 131. This pin will be like 131 comma 0, and this will be 131 comma 161. Okay, so these are the points that we have declared. So end x, end y1 is 80. This is the middle point. Okay, middle point is 65. Then end 2 40 32 0 0, and likewise. Okay, so like we are iterating and we are checking whether we are iterating it for like multiple times, 162 and 132. So whenever like either it comes to the starting position, that is this, right, or it comes to this position, right? So whenever like we know that the coordinate, the y coordinate is 0, right, or y coordinate is multiple of 132. If we consider like if when we are starting from here, it is considered as 0 0, it will go over like 131, and the next line will be like 132, or correct. So it becomes 1, right, 2 3 4 5 6 7 8 9 10 and 11 12. Likewise, then we want to display it like 0 to 131. So either x coordinate is 0 or y coordinate is 0, then we want to display one red line, right? Or what we want to do is like when this, right, the middle of the like x and y is equals to both are equal. Okay, so here you can see either both are equal or multiple of these lines, right? So basically what we are doing is we are simply using like whether if it is to this middle point or this middle point or that middle point. If that matches, then we are going to display the red pixel. Elsewise, what we will do is we will display the white pixels. That is the simple logic. Now simply like loop 1, if loop 1 multiplied by endpoint y, endpoint y is what, 161. Okay, so 0 into 161, it becomes 0 divided by 131. So anything divided by 0 is 0. Okay, so this becomes 0. that means the first condition is met, then display it. Okay, now in the second iteration what happens is it becomes 1. Okay, now 1 into, like, we are again loop 1 is 0, right? So it will display. We have not increased it, right? So we will simply display 1. Likewise we are going on and displaying everything. Now rest of the things are very similar, okay, and very straightforward, so I don't need to explain these things. Okay, we are just simply sending the commands that we have received from the datasheet. Okay, and after that, like, if we want to write the data, we are writing the data. If you want to send the image data, we are sending the image data using this command and data function. Okay, you can modify these functions and get, like, you can display the sine wave also if you know the formula, right? You can display a triangle also if you know the exact coordinates, and you can write it into mathematical format. Okay, or you can display anything that you want. So this was the explanation that I wanted to show. This is the, like, actual logical waveforms that we are displaying over here. Okay, so likewise you can follow it. Okay, try to understand the code, go through the code. If you have any problems regarding the code, ping me, send me queries on WhatsApp. My WhatsApp number is 966-500-1206. Okay, or you can connect me on my Telegram channel, that is STM Mechatronics, or you can put your queries in the comment box. So thanks for watching this video. In the next video what we will do is we will improve our code. Okay, so that this understanding of, like, whenever we are setting the bit pins, right, or we are resetting the bit pins, that we will try to reduce. Okay, we will try to make this code as simple as possible, and after that we will just simply use the SPI peripheral, so that this whole code becomes very much easy. Okay, so if you like my explanation, give the video likes, share with your friends. Again, thanks for watching the video. We'll see you in the next video.